Okay, good morning, class. So today we're studying our probability. Okay, so your homework was exercise 17.6. Yes. All right, so let's look at 17.6 quickly. We are told that 250 tickets were sold for a raffle. Stefani bought 10 tickets. What's the probability that Stefani wins a prize? So here we have the probability is going to be the number of favorable outcomes over the number of possible outcomes. Favorable is Stefani winning over 250. So it's going to give you 1 over 25. B does not win the prize. So does not win the prize is the complement of winning the prize. Not so. So those two events are complementary. You can either win or not win. Together, it makes the total of 1, which gives you now 24 out of 20. Okay. Look at number 3. Number 3, we are told that a plate holds 7 shortbread biscuits, 8 lemon creams, and 10 chocolate biscuits. The seven shortbread, 8 lemon creams, and 10 chocolate. 5 wafer, 15 wafer. If a biscuit selected at the okay, so how many biscuits are you in total? 40. Okay. Sorry? Not 40. Okay, so what's the probability that in the first case is either a lemon cream or a chocolate biscuit? So the probability is going to be the lemon cream. So the probability of the lemon cream plus the probability of a chocolate. Is there overlap here? No. So it's going to be 8 out of 40 plus 10 out of 40. Which is simply 18 out of 40. And 18 out of 40 gives us 9 over 20. B. It's not a wafer. So we can say the probability is going to be 1 minus the probability of the wafer. That's also what we call the complement. Okay. So that's simply going to be 1 minus the probability of the wafer, 15 over 40. 1 minus 15 over 40 gives you 5 over 8. Alright, you guys understand? Okay, number 5. Number 5, we are told that a packet contains red and green sweets. The probability of taking out a red sweet is 7 out of 12. What's the probability of taking out the green sweet? So the probability of green is 1 minus the probability of red. Why? Because they are complementary. So it's 5 over 12. 3. 35 of the sweets are green sweets. How many red sweets are there? So 35, so some amount of sweets times red, which is 7 over 12, give you an answer of 35. Okay, can you see that, people? So I divide both sides by 7 over 12. So the number will simply be 35 divided by 7 over 12. With an answer of 60. So there are 60 sweets in total. You guys understand? Alright. Number 7. We got 10 minutes before load shedding. Number 7. The only soft drink flavors available at the party were cola and raspberry. In total, 26 soft drinks were consumed. I think you're going to go with the Venn diagram here, no? You guys use a Venn diagram. What do you use? A tree. Okay, let's see first what they say. So only soft drinks were available at the party. The soft drinks were cola and raspberry. In total, 26 soft drinks were consumed. Okay, consumed means to say drank up, no? 9 kids had 1 raspberry drink only. 13 had 1 cola drink only. The remaining kids had 1 drink of each flavor. How many kids were there? Okay, so if it's 26 in total, 9 kids had 1 raspberry drink only. I think it's still good. Raspberry and cola. Okay. 26 were consumed. 9 kids had 1 raspberry drink only. So that 9 goes there. 13 had 1 cola drink only. Okay. Then the remaining guests had 1 drink of each flavor. So let the remaining guests then be X. How many guests were there? No. The only soft drink flavors available at the party were cola and raspberry. In total, 26 soft drinks were consumed. 9 had 1 raspberry drink, 13 had 1 cola drink only. The remaining guests had 1 of each flavor. How many? Okay, 13 plus 9 is 20. 30 plus 9, 30 plus 9 is 22. Not so. Which means to say there were 4 cool drinks left. And whoever was left, each had 2. So I'm getting 2. So answer 2. Okay. It's a bit confusing, eh? Did you guys find it easily? Huh? Okay, how did you work it out?
I said 13 plus
13 plus 9, yes?
and then the other 2 guests I had each.
Huh?
Plus 2 is
24. But it's 26. 2. And then you got 26. How else did you guys work it out? So you said 26 minus 9 minus 30 gave you 4. So your answer was 4. But we are told that the remaining guests each had 1 of each flavor. So of the 4 drinks that's left, there's 2 pairs there's 2 sets of people who had 2 drinks. Okay. So the Venn diagram is not the best fit thing. It was just a matter of logic, it looks like. Okay. What's the probability that the randomly chosen party guest had a cola drink? So how many colas were there? Now, 13 and 9 had raspberry and 13 had 1 cola. Okay? So, of the people who had 1 of each, how many of them were there? 2. So, in other words, the cola then gives me 15 out of 26. Why 24? Yeah, 24. 20. Why 24? Because there's two people that had two coins. Okay. Yes. Yes. Number the second one. Raspberry drink. Probability of raspberry. So there's 9 kids who had the raspberry plus the 2 extra. Yes. Yeah, you're supposed to have been 24. No? Yeah. Thank you. The raspberry drink. How many raspberry drink was there? 9 plus 2. It's 11 out of 24. Number 3. Both raspberry and cola. So how many people had raspberry and cola? So they give you 2 out of 24, which is 1 out of 12. Okay. Is that correct? So let's look at number 9. In a class of 38 learners at the girls' high school, 24 plays hockey. Right, this is definitely a Venn diagram. At the school of 38 learners, 24 plays hockey, 30 plays netball. The reason why I don't put it there is because they didn't say netball only. Okay. If they said netball only, then that 30 would have gone there. Okay. And 4 plays neither hockey nor netball. So 4 is on the outside. If a girl is chosen at random from the class, calculate the probability that she plays hockey and netball. So what we do is we say let hockey and netball equal x. So x goes here. Okay. So what goes for the hockey only? 24 minus x. How many does netball only? 30 minus x. But we know that 24, or we can say 24 minus x plus x. 24 plus 30 minus x plus 4 equals 38. So minus x is equal to 38 minus 4 minus 30 minus 24. Gives you negative 20. So x is 20. So in other words, this is going to be 20. 24 minus 20 is 4. 30 minus 20 is 10. But the question was to calculate the probability for the learner who does hockey and netball. So it's hockey and netball is equal to 20 over 38. And 20 out of 38 gives us an answer of 10 over 19. You all agree with that? The B part of the question is hockey only. Hockey only, as we know, hockey only is 4. Not so. So it's going to give you 4 out of 38. 4 out of 38 is an answer of 2 over 19. All okay with that? Let's look at C. C says, let's calculate the probability that neither hockey nor netball. Neither hockey nor netball is going to be 4. So it's hockey or netball not. Okay. Which is 4 out of 38, which is 2 out of 19. Do I have to write this like this? No. Okay. And then D, hockey or netball. So we know that the probability of hockey or net ball is equal to 1 minus the probability of not offering no net ball. You see that, people? So it's going to be 1 minus 2 over 19, which is 17 over 19. Huh? Not right? Otherwise, what you could have done was, for D, you could have said the probability would be 4 plus 20 plus 10 over 38, which is 34 over 38, which is 17 over 19 anyway. So whichever calculation intrigues you or you understand or prefer, you can apply that. Okay? You guys understand? Okay. Look at number 11. Number 11, we are told that 200 newspaper readers were asked if they read the business section of the back page, read the business section or the back page sport. 85, so again, Venn diagram. How many question? 200. Okay, so newspaper readers were asked if they read the business section or the back, so it's business and sport. Okay, 85 said they read the business section, so that's going to give you 85. It didn't say read business section only. 180 said they read the back page sport. 180. 15 that said they read neither of these sections, so 15 is on the outside. Okay. Draw a Venn diagram to illustrate this data. We just did. Okay, so we say let the reader who reads the business section and sport equal x. So it's going to be 85 minus x. And it's going to give you 180 minus x. Not so? Alright, so that's your Venn diagram. The first question says, calculate the probability that a randomly chosen reader involved in the survey reads the back page and not the business section. So in other words, we first need to solve for x here, not so. Right, so if you do that, so there's now B, the B part of the question. So we know that 85 plus 180 minus x plus 15 is equal to 200. So x works out to be, this is going to go out shortly, so it's 200 minus 85. Huh? Okay, it's 5. So x is equal to 5. Sorry? Negative 80. What's the answer? What is x? Negative 80. Now, who's giving us 5? Is 85 minus 180 minus 15. Gives you negative 80. So x is 80. How do you guys get 5? So then this is going to be 85 minus 80. Oh, is this your 5 we're talking about? And that is your 80, and this is going to be 180 minus 80, which is 100. So the question says the probability that the back page sport, but not the business section. So that means to say the sport page only, in other words, which is 100 over 200, which is half the people. Okay, let's look at number 2. Both business section and the sports page. So that is going to be 80, not so? So it's going to be 80 over 200, which is 2 over 5. Okay, 2 over 5. Yes? Sorry? What's wrong? 18. It says both the business section and, so this is the intersection. So business section and sport. It's going to be those partners. Okay, which is simply 80 over the total, which is 80 over 200, which is 2 over. Okay, any other confusion, people? I think at this point we have answered all the odd numbers from 17.6. You all agree with that? Alright, which basically brings us to the end of this chapter. So what you guys can do is you can do the even numbers and we can discuss in our next lesson if there was any issues with regards to that thing. Okay. At this point we'll stop the video.